Welcome, my name is Elbin, and throughout this presentation I will be discussing sustainable geotechnics from my research paper. This is a critical field addressing environmental challenges through innovative engineering that tackles climate change and resource scarcity. We'll see how recycled materials, biotechniques, and renewable energy can build resilient infrastructure while healing our planet. So why sustainable geotechnics matters? Well, climate change and resource depletion demand urgent action. Traditional methods like cement production actually harm the ecosystem, but sustainable alternatives like fly ash, microbial soil stabilization, and energy piles actually slash these emissions and conserve resources and create infrastructure that lasts. So, what's the problem? Understanding that conventional geotechniques relies on carbon-heavy materials like cement and chemical grouts, and these methods offer short-term fixes but cause long-term damages, such as resource depletion, pollution, and fragile infrastructure. We need solutions that balance performance with planetary health. Well, my research focuses on recycled materials like fly ash, biomethods like microbial calcite precipitation, and energy efficient foundations, as well as addressing barriers in inconsistent policies and training gaps to bridge the gap between labs and real world projects. So, what do we know? Well, studies prove that fly ash boosts soil strength by 42%, and microbial calcite precipitation fills soil voids with calcite. But gaps remain as field data is scarce, regulations are patchy, and engineers lack training. So, how would we test sustainable geotechnics? Well, lab experiments measured strength and permeability of materials like fly ash, and the real world case studies like Rotterdam's ash embankments, California's bioslopes, and Stockholm's energy piles show how these methods perform under actual conditions. And the key findings from my research is that fly ash mixtures cut emissions by 25% while strengthening soil, and the microbial calcite precipitation filled 6 to 70% of the voids with calcite, stabilizing the slopes. And energy piles in Stockholm slashed HVAC costs by 38%, which the data proves how sustainability and performance can coexist. So, a surprising insight from one of the recycled materials in microbial calcite precipitation is that it initially costs 80% more, but it does reduce maintenance by 40%. And we see how Rotterdam's project faced skepticism, yet its success changed regional policies. And we also see how higher upfront costs pay off long term, like Stockholm's 7-year payback on energy piles. Why is this transformative? Well, these methods protect ecosystems and align with United Nations Sustainability Development Goals and create infrastructures that outlast climate threats. And they're not just eco friendly, they are economically smart, they are socially responsible, allowing us to build safer and cleaner communities. Now, closing up on my presentation, sustainable geotechnics works, but we need more field data, stronger policies, and better education. We need a future where infrastructure heals our planet. Once again, my name is Elbin, and I thank you for watching.